So, hi everybody, so I'm Jonathan from Imperial. Today talking about OpenMOLE, a workflow management system. Just to see quickly, who's using any kind of pipeline management, workflow management system at the moment? Well, you're all sitting on the side, right? It's nicely spread. And who's using any kind of HPC facility, clusters, grids, anything without it? Cool, so about half of it. Great, so this is a joint work with some colleagues. They actually are the concept of this thing. I joined the project later, back in France. This is the kind of problems we're trying to solve. On a daily basis, you are manipulating naturally parallel things on your laptops for lots of different problems. Can be data reconstruction, primary estimation, lots of different things that you do. The important thing is what you're doing is executing the same program, that might be your program, that might be a sequence of programs, against different parameters and against multiple data sets. So this is a bit slow if you do it on your computer alone, right? And the thing is, we all have, or pretty much all have, hopefully in our labs, HPC or distributed computing facilities that should allow you to simply parallelize that. But this is not always simple because there's lots of constraints when you're trying to access these kind of environments. So the idea here is to see how we can easily help you to prototype on your machine and without changing anything, directly access this upscaling power from these distributed computing environments. This is the three main concepts that guide the platform and that help us doing that. So on the top left corner, you got what we call the models. I'm going to tell you a little bit more about it. This is basically your application. We see it as a black box. We don't want to know what's in your application. We just want to know what it takes as inputs and spits as outputs. And as John said the other day, it's not always easy to make people say, what are the inputs, what are the outputs of your application? But I assume that you guys, for you, it's fine. In the second point, we got the method. I'm going to skip quickly on this one because that might be a little bit more advanced for today's talk. It's basically all the parameter exploration methods, the advanced parameter exploration method that we provide from the platform. The naive approach would be, I have 3 parameters. I do a Cartesian product of all these parameters to explore them, or I do a random search in my parameter space if it's too big. In these toolboxes that we have here, you got more advanced methods that allow you to sample the parameter space a little bit more in a smarter way, I would say, and maybe sometimes to discover some not predicted patterns for your application. But all these things lead to either simplifying the access to massively parallel environments, or they generate a huge workload. When you do a parameter exploration, it generates a huge workload. So you want and you need these massively parallel environments. All of this is guided around a workflow formalism, so a set of tasks connected to each other by their inputs and outputs. And we express this thing with a domain-specific language, like a high-level scripting language that we've defined to model these workflows. So this is what we call a model. So it's a box that you can run, and that takes inputs, any kind of it, and give you outputs when it's done its computation. So I guess it can apply to pretty much everything you're doing. For this to work, we do not provide any ready model in the platform because we are a community agnostic platform. We do not target specifically neuroimaging or anything. There's like people doing social sciences and geography using the platform as well. So the idea is you come with your application, and we embed it in the platform when you need to run it. And for that, we promote something called the zero deployment approach. So if it runs on your machine, you've got everything nicely installed. There's no reason that you'd have to reinstall everything on the execution environment. So the platform will take care to ship your application to the remote environments and all the dependencies, the files, the input files that you might need to have to successfully rerun your execution. We work with anything as long as it can be executed on Linux. Of course, if it's a proprietary software, we do not generate licenses automatically. Cannot do that. So you have to have the licenses installed on the cluster, for example. But for anything that is free and open source, we can embed it in the platform. How do we do that? I say for non-JVM applications, so JVM for Java Virtual Machine. So whenever you're using the Java Virtual Machine, you got a very simple way to package application. You've seen it with XNAT. It comes as a big WAR file. Well, for desktop applications, there's the same thing with jars. So you can generate an archive for any application running on Java. For other applications, it might be a little bit more complicated because you need sometimes shared libraries. You might need other configuration files and all these things. And the big problem we have is, unfortunately, we can't use Docker in most of the environments we're using. Docker is amazing, but when you're not system administrator on the platforms you're targeting, well, you can't install it. That's the thing. And it's very, very hard to convince these guys to install Docker most of the time. So that's one of the constraints we have, is to run on remote environments where it's very likely that we don't have Docker, but we still need to package our applications and along with that, all their dependencies. So for that, we use something that we don't develop that is called Care. I've put the link there if you want to check it. The idea of this thing is you will execute your application as you do normally with one of the set of the parameters that you would use, and you will pass it to Care. So just prefix your application with this thing. This tool is going to capture all the dependencies of your application, so the shared libraries, the configuration files, the environment variables. Basically, everything your application is manipulating is going to be detected by Care and put into a nice standalone archive. What I intend by standalone archive is something that you can take with you on any other machine, rerun it without having to have anything installed beforehand. And as far as we know, it works fairly well on any kind of Linux, from any kind of Linux machine to another Linux machine, even if the differences in the kernel version. It can handle it. So just 3 steps. Package your application with Care, write the DSL workflow, click play, it works normally. This is just if you need to make sure your application is available in the remote environment. If you are using a cluster that has all the tools already installed, you don't even need to package it. We can use it directly. So I skip directly to what do we intend by massively parallel environments. This is what we support as of today. So pretty much all the clusters, they're not all there. There's others a little bit less popular. So you got the main ones. In the middle, you got the what we call EGI. So in Europe, the European Grid Infrastructure. It's a network of clusters. Got basically 600,000 cores available on this thing. Mostly used by physicists, but it's also good sometimes to take a little bit of CPUs from them. This is tomorrow. When I mean tomorrow, I mean hopefully very, very soon. We are actively working on making AWS available. And with AWS, hopefully the next step will be execute Docker containers as well. Because when you're on the cloud, you master the installation, so we can make sure that Docker is available on the remote environments. OK, time to show you what I mean by all these things. So I've prepared a little thing. I'm going to show you first. I'm reusing the XNAT instance from the practical sessions. I've just created a simple project with three subjects. And each of these subjects has got an MR session in which I've put just a nifty file. All right? So the idea of this thing will be retrieve the nifty files from this XNAT instance, apply a basic registration algorithm on that, and retrieve the results file afterwards. How do I do that? So where is that? This is it. So I already apologize for my very limited Python skills. I don't do Python, so This is just as an example for you. I've just used XNAT to retrieve the files. And basically, this is what it's doing. So blah, 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 just a function to apply the registration. But mostly, the most important thing is here. This application takes the subject ID and XNAT configuration as parameters. It retrieves the corresponding files from XNAT with this wonderful function that I've written, and then applies the registration to this image and the first one as well. And then when it's done, it's going to write the result of the registration to an output file that we store in /temp. All right? So hopefully this works. But as you can have seen at the beginning of the file, I'm using a couple of things to make this work. So I'm using simple RTK, I'm using XNAT. So this is already 2 Python packages, plus potentially all their own dependencies. So if I want to take this application and execute it elsewhere than on my laptop, well, I will have to somehow package all these things. How do I do that? I run this command line. So if you forget about all the beginning, so if I just highlight the rest, this is just basically calling a Python script from the command line as you would do anytime, all right? This would be the regular call of your application. Now, just prefixing it with the call to care and telling it to generate this archive in the local folder will, if I run it, execute my application as it would, and it is actually capturing all the dependencies, and once it's done, will generate this registration example.bin. All right, so now I have my archive packaged. I don't know how long does it take, so I've prepared it in the OpenMOLE session. This is how the application looks like. So it's a web interface with a workspace on the left where you have all your files that you can manipulate, and a text edition box in the middle to design the workflows. So I've prepared a workflow for this application. What we're doing is, as you can see here in the main node, just re-executing the very same application that I've shown you from the command line, right? But for that to work against different parameters, I have to give it a subject ID and eventually this XNAT configuration file. Where does it take it from? Well, I say, in inputs and outputs, you will take this subject ID. We will see later what it is. You will provide me an output file, and you will name it subject underscore subject ID underscore what. And I will give you as a resource this file. This file is available here in my workspace. If I open it, it's just, I would love to open it. Well, you have to trust me. It's just like basic configuration for XNAT. And on the first line, I give to OpenMOLE the archive that I've generated before. So it knows where to find the package code. Now, how do I run that? Well, if I can zoom out, yes. Here I've got the tasks that we've defined here just above. And I say, you will run an exploration before this task. What is an exploration? It's just filling in the subject ID variable that we've seen before. So this variable is kind of a special variable in OpenMOLE that is able to take multiple values, like a vector, but hidden from the user, that will then generate the parallelism. So I will fill this vector with values from 0 to 2, so 3 values, basically. And once I connect the workflow, all these values, each of these values will generate a different instance of this registration task. And this registration task will then have a different input parameter for each of the values in the subject ID variable, so 0, 1, and 2. The hook that is afterwards is just a way to retrieve the output files when it's generated on a remote environment to automatically bring it back on your host machine. So this is a complete workflow. And if I hit play, the script is compiled and starts to run. When I mean the script is compiled, I mean all the data types are verified. So you cannot use an integer where the application expects a string, for example, or vice versa. It checks as well that all the inputs and outputs that you've specified are valid, that you're not missing any input-output in the middle. Why? Because when you run these large-scale experiments, the last thing you want is for it to fail in the middle of the pipeline once you've run everything for a week already. So you want it to fail fast so that you can quickly fix your workflow. So at least when it starts to run, you know that everything is syntactically correct. It's like a compiler to generate binary. While I was talking, the application has been running the workflow. So you see that 3 out of 4 tasks have been completed. 1 task is the exploration itself, and then we've got 3 instances of the registration task. So it's finished. I can now verify that it has retrieved files in my folder. Yes, so I've called them subject. So you see that there is 3 files that have been generated. Now when it becomes really cool is this thing has been running slowly and sequentially on my laptop. Now the very same thing can be sent on a Slurm cluster just by adding this thing. So I define a Slurm environment, and I say, OK, so to connect to the head node of this cluster, which is called Predict 5 at Imperial, you will just use my login here. And this is just another parameter, use this queue. I then say, well, which task do you want to run on the cluster? I don't want to run the exploration because it's very short. It just generates input, so I don't need to run this one. But the registration, I might want to delegate it to this cluster. So I will say, OK, the exploration is going to run on Slurm. And that's it. Now if I click play, and if my VPN works, this execution is going to be sent to the Slurm cluster of my lab. So we can see that it's a bit different now. I have a Slurm environment that is defined, and we'll monitor the jobs that have been submitted, the data that have been uploaded and downloaded, and all the jobs that are actually running. To do that, I didn't change anything apart from declaring my environment and saying where my task was running. I can add as many environments as I want with different constraints. And I have the granularity to either group several tasks together to send them together on an environment, or to decide that each of the different tasks are going to run on different environments. Typical use case, you've got a task that is GPU accelerated, but not all the others in your pipeline. So you may want to benefit from these GPUs at the beginning of the pipeline, and then use another environment which has more CPUs, for example. So in this case, you'd be able to define 2 different environments and split the definition of the tasks. And the only trick to do that is I have to define authentications for each of the environments I'm using. So we support login passwords, private keys, or certificates if it's agreed environment. So the native things that you would use for these environments. And that's it. So we can check whether it's still running. So I guess the VPN doesn't like it too much, but you'll have to trust me that it works on this different environment. One last thing before I conclude. The easiest thing to get to grips with the application, we have some tutorials, but we also have a marketplace. So when you are inside the application, you can hit the little tray there, and you can retrieve all the examples from the marketplace directly. So if I click on this one, for example, I can download it directly to my workspace and start to play with a workflow that is already written for you. So that's a good way to get started. Instead of writing workflows from scratch, you can modify something that's already running. And that's pretty much it for me. A bit of links if you want to check the documentation, source code, and websites. And a big thank to my collaborators as well. Thank you for listening, and more than happy to take your questions now.
So I have a question. So this is kind of designed that you go to OpenMOLE as your user interface where you're controlling the various actions, which I'm sure makes a ton of sense in a lot of the use cases. But I'm also imagining they might have use cases where you want these things to be triggered by some kind of event. Is there an API or interface with it that you can imagine an XNAT event happening, that trigger MOLE activity?
So this is only one of the 3 modes of execution that we have, the web interface, the one we promote because it's the simplest for most of the users. There's also a console mode that is the very same thing, but you got a prompt basically that allows you to type the comments that you've seen in the text box. And there is also a REST API that you can reach remotely. It's still a little bit in development, the REST API, but we will try to improve it over the next few months, hopefully. So that would be the way to trigger something from XNAT, I guess. And the other way around, what we'd like to do is, instead of having to call PyXNAT to retrieve things, it would be to be able to specify XNAT queries within the exploration itself. Say, explore this project and all the subjects that are this age or something like that. That would be amazing.
Very cool.
Yeah.
Is there functionalities for, say, that could say you have to do 50 tasks, and then a task after that can run after those 50 are complete?
Yeah. So it's a classical workflow. So for example, if I were to say that another task has to run after that one, I would just say sequence and task 2. That's it. There's lots of different transitions to generate this. You can run like multiple tasks in parallel. You can run an aggregation as well. So multiple things.
Are they when you package up the executables, want to push them to some particular environment? Are those cached at that environment then? Is there
kind of. So we have there's also a database that runs in the background as a separate process, and that manages a list of everything that you've uploaded somewhere, a list of replicas. So if it's been uploaded once, it's not going to be uploaded a second time, apart if you change it.